Look at our home. Earth is a giant, beautiful blue splash zone. More than 70% of our planet is covered in deep, sloshy water. We drink it, we swim in it, and it's the main reason we are alive today. But here is a secret. Earth was actually born completely dry. 4.5 billion years ago, our Earth was a hot, angry ball of melted rock and dust. It was so incredibly hot that any water on its surface would have boiled away instantly into the cold freeze of space. If Earth started as a dry rock, where did the oceans come from? For a long time, scientists had a hypothesis. They thought faraway space rocks, acting like giant frozen water bottles, crashed into our dry Earth and brought us our water. But it was just a theory. On September 24, 2023, NASA's OSIRIS-REx spacecraft returned to Earth from the asteroid Bennu. It provided the first pristine physical sample that could finally allow us to test that theory without any interference from Earth's environment. When scientists got the space capsule into their ultra-clean laboratory, they ran into an immediate problem. 2 of the 35 metal screws holding the container shut wouldn't budge. The main sample was locked away for 4 whole months. Because the space dust inside was so delicate, they couldn't just use a normal hammer or a standard screwdriver. That would risk contaminating the cosmic recipe with Earth's air. They had to spend months designing brand new custom tools just to open the jar safely. But while the engineers were building new tools, other scientists noticed the robot had been a bit messy. When it scooped up the dirt from the asteroid, a layer of loose dust and pebbles got stuck on the outside of the collector head. They gathered this bonus dust and put it under their microscopes. Right away, they found that this dust was packed with carbon and clay minerals, the kind of minerals that only form when water is present. Even before the primary container was opened, this external dust proved that Bennu carried the chemical signatures of a water-rich world. Inside your body, you have a set of instructions called DNA. It tells your body how to grow everything from your eyes to your fingers. This instruction book is made of 5 special chemical letters, which we call nucleobases. The sample contained adenine, guanine, cytosine, thymine, and uracil, the complete set of genetic letters for life. Past meteorites risked Earth contamination. Because this space dust was sealed in a sterile container, we know these building blocks are floating out in the dark. This chart compares the carbon found in typical meteorites with the sample from Bennu. While most space rocks contain only trace amounts, the carbon in this sample jumps to nearly 5% of the asteroid's total weight. The sample is also packed with wet clay minerals. These minerals have actual water molecules trapped inside their physical structure. This analysis proves that the ingredients required to build a habitable world are not unique to Earth. They are part of a widespread recipe used across our solar system. Today, Bennu is just a small, quiet rock about the size of a skyscraper, but its chemical makeup tells a much larger story. It's a fragment of a massive, ancient parent asteroid over 100 kilometers wide. This parent world was so large that its interior was geologically active. This allowed liquid water to flow, mix, and react with minerals deep underground for millions of years. The smoking gun is a mineral found in the dust called trona. On Earth, trona only forms when salty lakes or rivers evaporate, leaving a mineral crust behind. Its presence on Bennu proves the parent world once had a warm, salty, flowing water system. The dust also contains ammonia. Because ammonia is highly volatile, it can only survive in extreme cold. This confirms that the parent asteroid formed in the freezing outer reaches of the solar system, far beyond the orbit of Jupiter, before eventually migrating inward. We see these same signatures elsewhere. The magnesium-sodium phosphate found in the Bennu dust is the same compound detected in the geysers erupting from Saturn's icy moon Enceladus. Bennu is a surviving piece of a vast, water-rich network from the outer solar system, a network creating the exact organic chemistry needed for habitable oceans. For the first time, scientists can compare Bennu's chemistry directly with the sample Japan's Hayabusa 2 mission brought back from the asteroid Ryugu, giving us a clearer look at how these cosmic delivery ships differ. The OSIRIS-REx mission returned 121.6 grams of space dust. This is more than double the original amount NASA aimed to collect. Despite having this abundance of material, NASA has locked 70% of the sample away in pristine, untouched storage vaults. They are saving it because they know that 50 years from now, scientists will have built more sensitive microscopes and analytical tools. We are preserving these samples so future generations can solve problems our current technology cannot yet address. The story of our water began when giant icy worlds in the outer solar system were shattered by collisions. Fragments like Bennu were sent hurtling into the inner solar system, raining down on our dry Earth to cool its crust and fill its basins with the ingredients for life. The next time you take a drink of water, remember its origin. That water isn't just from Earth. It's a 4.5 billion-year-old delivery from the deepest, coldest corners of the cosmos.